Let me show you this implementation in just a little more detail. We have extended our curly grammar with Letrec, but we're also going to add an if zero form in because that's handy for writing recursive functions. That way you can make them terminate as test cases. So we're going to add if zero in Letrec. We have our interpreter based on the Lambda interpreter. We have if zero here and Letrec E. And you can see the parser, we're now just encoding let using lambda, so we won't worry about let, but we're not going to encode letrec. For the letrec, the parser looks similar to the old let parser, except we form a letrec E now. And if zero is going to be straightforward. And the if zero evaluation just says if the first argument produces zero, then interp the left and right. Letrec is the interesting part. Here is that pattern that we show on the slides. New emb is set up first, binding in to a lambda that delays the reference to val. Meanwhile, val is interpreting the right-hand side with the new emb, and then we can interpret the body with the new emb. And we have some test cases here. And then at the bottom we have that revised lookup that has the extra pair of parens around bind val. You can see the test cases have been updated to wrap a lambda around all of the values in the binding. We can run this factorial example directly. So this is the factorial function written in the obvious way, and it's using our letrec that's not encoded now, but implemented with Plait's letrec. And so we do get the number we expected for factorial 5. As usual then, we are able to use Plait's features to implement Curly's features, but that feels like a cheat, and it is. So we're going to go back and do it again without using this metacircular approach. But there's also a problem with our metacircular implementation. Let's try the example where we try to let x be x and look up x. What do we expect to happen in this case? What Plait says is that this would be a too early reference to x if we looked at this as a Plait program. So Curly should do something similar. What actually happens is that we get an error message. It is the cannot use before initialization message, but it's about val, not about x, because of course that's what goes wrong in our interpreter. It turns out that we do end up calling this function that looks at val before val itself is initialized, and so that's why the error message says val instead of x. You might view that as a minor problem, but just that the name is wrong, but it's actually a deeper problem. We couldn't test this. We can't write test exn use before initialization. If we try that, then it still claims that the test fails with an exception. And the problem here is that it's not a curly exception. It's not an exception raised by our interpreter. It's a Plait level exception. And that means it's things outside of our control. Those are exceptions that we can't catch because it was a problem in our interpreter, not an error that our interpreter raised. So to really understand letrec, we need to go a step further and not use this metacircular approach.